Okay, so welcome back. Now in this example, we're going to do it two different ways, okay? One is going to be using a U substitution. Now looking at this, you may not see that you could use a U substitution. This is where, again, you just got to look and see how we might be able to manufacture a U substitution. Okay, so let's do that first, and then we'll do the trig substitution, because in this case here, again, you could use a trig substitution and watch, you're going to get the exact same answer. Okay, so let's do the U substitution first. Now the way to see that you can do a U substitution is to say, hey, let U equal, obviously we want U to be this underneath the radical. So this is going to be 1 minus x squared. Okay, now we've got an x cubed here because we got du. Du is just going to be equal to what? It's going to be equal to negative 2x dx. Okay, so then what we'd have to do is we got a negative 1/2 is equal to x dx. Okay, now we've got an x here. Now here's where you see it. If you got an x here, well, let's match it up with one of those. So if I can just rewrite this, I've got x squared times 1 minus x squared, and then I'm going to just have x dx out here, right? So now I've got my x dx, and I've got an x squared. Well, u is equal to 1 minus x squared, so I can solve this and say x squared is equal to what? 1 minus u. And so there I have it. So now I can write this as what? 1 minus u times the square root of u du with a negative 1/2 out here, right? So the negative 1/2 du. And so now I can just distribute this, and I get the square root of u minus what? This is going to become u to the 3/2, right? Because I can write this as u to the 1/2, and this is u to the 2/2. So I get u to the 3/2, and I get this, right? So I can write this as u to the 1/2 du. And now I just integrate. So I just get negative 1/2, and I get, well, what do I get? I get this becomes 3/2, so I get 2/3 u to the 3/2 minus, well, this becomes 5/2, so I get 2/5 times u to the 5/2 plus c. And now what happens? This becomes 1/3, right? I'm going to distribute the 1/2 now. This becomes 1/3 u to the 3/2 minus 1/5 u to the 5/2 plus c. And then now I just put my x back in. Well, what's x? Or excuse me, what's u? 1 minus x squared. So this becomes what? 1/3 times 1 minus x squared to the 3/2 minus 1/5 times 1 minus x squared to the 5/2 plus c. So that's my answer. So I get 1/3, 1 minus x squared to the 3/2 power minus 1/5 times 1 minus x squared to the 5/2 power plus the constant c. And I'm done. Okay? So that's the easier way of doing it, if you see it, right? So again, always look for an easier way to solve these if it exists. Again, it may not exist, but that's the answer. Now watch. Let's do the same thing, and we're going to do a trig substitution. Okay? So now I'm going to do, again, it's in the form, right? So I'm going to use my x equals, in this case, a is 1, right? 1 squared is 1, so a is 1 here. So this is just going to be sine theta. So dx equals cosine theta d theta. Okay, now watch. I'm going to do my reference triangle. So in this case here, what do I get? Well, this is just x over 1, right? So this is going to be x1, and then of course this is going to be 1 minus x squared, the square root of that. Okay? And so now if I do this, let's do my substitution. Okay? So this is going to be the integral of sine cubed theta times, 1 minus right? And this is going to be cosine theta d theta. So I get this. And now notice that this is going to simplify very nicely. So I get sine cubed theta. This here is just 1 minus sine squared theta, which is just cosine squared theta. So this is going to be the square root of cosine squared theta, and I get cosine theta d theta. And so now, what happens here? Well, again, this is going to simplify to cosine theta times cosine theta, which is going to give me cosine squared theta. So this is going to be sine cubed theta cosine squared theta d theta. Okay, so now, look what I can do here. So in this case, now I've got a product of trig functions, right? So this is product of powers of trig functions. Okay? So what do we do with this one? So now I'm going to shave off, because remember, odd power, right? So I'm going to shave off one of the signs, and so I'm going to write it as sine squared theta cosine squared theta sine theta d theta. Okay? So now why am I doing that? Just like before, I'm having that. So what's my u, right? What does my u have to be? Well, I'm going to make u cosine, right? So cosine theta is going to be my u. And so I know I'm going to have a sine theta d theta that I'm going to make my du. So this is my du. So now I know I have to change this into terms of cosine. So that means I'm going to use the Pythagorean identity again. So this is going to be 1 minus cosine squared theta times cosine squared theta, and then sine theta d theta. Okay, so now I can do my U substitution. So this is going to be what? It's going to be, this is 1 minus u squared times u squared times du. And now, watch what happens. Now I get the integral of u squared Yeah, that's right. So I get u squared minus u to the fourth du. And of course, if I integrate this, this becomes 1/3 u to the third minus 1/5 u to the fifth. And then of course, if I put back in for u, okay, or hold on a second. Yeah. So if I put back in for what u, oh, plus c. So now if I put back in for u, I got to go back in terms of, theta, right? So this is going to be cosine theta, right? Yeah, u is cosine theta, so this is going to be 1/3 cosine cubed theta plus 1/5 cosine to the fifth power theta plus c. And now, back to my reference triangle. Okay, so what's cosine theta? Cosine theta is adjacent over hypotenuse. So it's just this. It's just this. So this is going to equal 1/3 times the square root of 1 minus x squared raised to the third power plus 1/5 the square root of 1 minus x squared to the fifth power. Which of course, if you write the radical as a power, right? So 1/2, then you get the same thing that we got before, which is 1/3 1 minus x squared to the 3/2 plus 1/5 times 1 minus x squared to the 5/2 plus c. And we're done. We got the same thing. Okay. Well, obviously, the first method was, I think, easier. Okay. But nonetheless, you can also use trig substitutions to get the same result. Okay. So now, here's what I want you guys to do. So here's one for you guys. In fact, I might have a couple. Do I have a couple here that I want to give you? Okay, here's one. So try this one. The integral of x cubed over 25 minus x squared dx. So now, use the appropriate trigonometric substitution. Now, again, just set this up and simplify it, but don't evaluate the integral. Unless you want to. Unless you want to try to, that's fine. But do not evaluate the integral. My main thing is practice doing the substitutions, make sure the substitutions are done correctly, and then simplify it, the integral, as much as you can. And then leave it at that way. But if you want to try to integrate it, that's fine. But see what you can do. Okay? Take care.